Hello, welcome to Carnegie's live virtual event, Setting Moonshots on Target, US-Japan Strategies for Technology and Science Investment. We're glad you can be with us. My name is Jim Schoaf. I'm a senior fellow at the Asia program at Carnegie Endowment for International Peace. I run the Japan program there, which increasingly has been focusing on the intersection of technology and our economic prosperity and national security, but from an alliance context primarily. And if you tuned into us today to hear about Saturday's rescheduled SpaceX launch, that's not the kind of moonshot that we'll be discussing. But I think you won't be disappointed by sticking with us. Instead, we are using Japan's so-called Moonshot Science and Technology Investment Program as a way to examine the whole broader field of high-end international science technology collaboration. The United States and the European Union have similar programs, spending billions of dollars, aimed primarily to address some of our planet's and humankind's most crucial challenges. And we'll discuss them in our first session for the next hour or so. And then we'll have a second session later tonight to look more closely at specific examples of US-Japan research collaboration in artificial intelligence, high energy density science, and other areas. First, we'll hear today an overview of the Moonshot program, Japan's new science and research initiative, from Dr. Hiroaki Kitano. Kitano Sensei was a member of the Visionary Council that helped design the Moonshot program. And he's also president and CEO of Sony Computer Science Laboratories, among other work that he does primarily in the field of artificial intelligence. We are also joined today by Dr. Irwin Gianchandani, the Deputy Assistant Director for Computer and Information Science and Engineering at the National Science Foundation. And he has intimate knowledge with the 10 Big Ideas program that NSF oversees. And we have with us Dr. Mary Kavanagh, Minister Counselor, Research and Innovation for the EU delegation to the United States, who will talk about Horizon Europe and international cooperation from her perspective. And we have a special guest today, Mr. Koichi Akeishi, who is Japan's Vice Minister for Policy Innovation in the Cabinet Office and a prime kind of architect or catalyst for the Japan's Moonshot initiative. So we're glad Akeishi-san can join us from Tokyo. So I'm going to get right to it. Kitano Sensei, can you get us started with an overview of the Moonshot program and provide some insight into your thinking and what went into the design of this?
Okay, thank you very much. Let me share my experience with the Japanese Moonshot program. Basically, this is a public sector Moonshot operation. And I was in Visionary Council. I mean, because this is a government initiative, like we got a bunch of committees and all the members and all the formalities, as you can see. And I was one of the members for the Visionary Council, which is supposed to define the overall architecture, and also like a possible candidate moonshot target. And then this is supposed to be finalized by the system, which is the higher, very high like research development council of the Japanese government, and also like decided by the prime minister. And then what we actually decide to do is define what the moonshot. So basically, you can really see there are different kind of research, which is one is the moonshot, which is you want to invest a lot, and you want to have like a very tangible and visible and publicly appealing result. At the same time, if you look at the slide, the right end is exploratory research. This is really the curiosity-driven, the basic research, which is like a kind of research in the US, like a National Science Foundation might fund, or like NIH R1, R01 kind of research. So we have like with a very clear recognition, there are different kind of modality of the research, and we're focusing the moonshot, which is a very clear target, and invest in a quite substantial amount of money. And so the difference, like a moonshot, obviously come from the Apollo project, right? So like Apollo project, you got like a one target and it go to the moon, and the time horizon was 10 years. And so it's a very visible program. And a Japanese moonshot, this is really not just like it's difference from Apollo. This is more or less a combination of the deployment project at the same time, like implication of basic research. So we set the target much longer. We set the target 30 years. The hope like a government can maintain that scheme. And then instead of having one goal, and we decide to have like a big larger number of goals, like we set the 25 candidate goal, which expect they're expecting the, like the government during the process to select a handful of goals, which is practical because the 25 goals is obviously too much. And you have to come up with like a 3 or 5 goals. Like even that is probably a too big in terms of number. And then difference of the Apollo and then Japanese moonshot is we are focusing more on the techno-social transformation. Because if you look at the big issue facing today, like a climate change and then all the issues that requires not only technical solution but also social transformations. So you're focusing more on the techno-social transformations. Okay, so that's what we are trying to claim. And of course, like we had like a case study. One of the case study which I'll come back later if I have time is like a RoboCup as like one example of the recent moonshot, which actually I initiated over 25 years ago with the number of researchers around the world. In the US, Professor Manuel Veloso from the CMU and Peter Stone right now for the Austin is actually leading figures in the RoboCup initiative in the United States. The idea is to create like a fully autonomous human robot to win the FIFA World Cup champion by 2050. And we start this challenge early in 1990. And then, we get the global initiative. And in the result, we get a lot of technology push and then also a spin out. One of the success spin out is a Kiva system, which is now Amazon robotics and transforming into logistics. And then all the kind of ecosystem we build up. So we, kind of model partly like a success of the RoboCup. And of course, like we learned a lot about the Apollo project and the other major scientific initiative. And in deciding what is the Japanese moonshot mission, we have like 3 bigger areas. One is facing aging society, particularly in Japan. Japan is the leading country in aging society. And the second sector is like environmental climate issues, saving us and then what we the new form of the industry or technology to solve this global climate issues. A third one is not necessarily linked to social issues, but like what kind of disruptive innovation we can have in science and technology? What is like very crazy goals that we can actually set up? So like we decided that there are 3 areas which is in a bigger framework, and then all we decided to do is to come up with like a specific goal candidate within those areas. So one is like an aging society. We wants to be have like a more social inclusion. At the same time, we want to have like a much stronger healthcare, more disruptive, more innovative healthcare. Also, because we have like our labor shortage is obvious, like what we decide to have is industrial innovations. How can you compensate for the shortage of laborers? And so like we have like a big push in autonomy, autonomous systems. Along that, we break down into a few targets, which is the yellow side is much more concrete. It is, for example, we want to have like a cyborg technology, we want to have autonomous robotics and avatar technology, we want to have like preventive medicines, we want to have food automation or the different kind of industry. So those are the things we are looking into the Japanese issues in the aging society, which probably like most of the Asian and European countries will follow. And the second sector was actually saving the earth. So one is like we are putting a lot of burden on the this planet. So reduce resource demand or reduce the material and energy requirement, and also to restore the global diversity. And those are the 3 areas that we consider very important. Among that, we break down into the some of the areas. For example, reduce resource demand. What happens if we put the challenge by reduction of the resource, demands, the hundreds, right? So it's a significant risk demanding, and also like computing costs will skyrocket. Can we actually significantly reduce the computing, energy consumption for the computing? Or like use the material energy, like 100% energy sufficiency, recycling on the resource, and then the garbage issues and the food loss issues. Like those are the issues that we can think about. Okay, and also restore global biodiversity. Can we actually create the agriculture which enhance the biodiversity rather than the monoculture, or I think other things? Okay, or terraformations maybe. So we come up with like all possible logical options which may require, and then put the possible target. Okay, and then the third, which is like this, right? And the third category is the what disruptive thing we can do in science and technology is basically we focus on the measurement, computing, and manipulations at the various scale from quantum to the space. Okay, that was actually fundamental. And one of the things is that we want to actually explicitly, recognize the combination of big science and exploratory science. For example, this is an example of how the Professor Yamanaka came up with IPS. So it was, it's not come out of blue. It was like a big government project trying to get like all the genome, gene characterization of the mammalians. And Professor Yamanaka used this system to identify the 24 genes which enable cell to reprogram it. And then decided to successfully identify the 4 genes which is essential to form the IPS. So this is a really combination of big science and exploratory science. So in a Moonshot, we want to have like a very disruptive big science which can actually foster exploratory science in a very accelerated exploratory science. So what we decide to do is one big thing: automation of scientific discovery, like AI, robotics, do the science by itself, and reduce reproduction and controlling the biological process, and in-depth understanding the neural system, and visualizing the Earth and quantum to Earth, and then permanent presence in the space, and then all that. So from the biology to microscopic to the space, we decide to have like a automation of science and a very different kind of measurement and control. Okay, so we come up to 25 goals. Doesn't mean we have to do everything. Like it's resource-wise it's not possible. That's expecting among this we have the selection process, a priority, and select a very small number of the goals to be seriously considered. And that was the initial intention. Now, all those are not really random. It's really tightly connected. This is kind of a very simplified network diagram. We have a very dense diagram how those technical and scientific discovery can be interconnected. Okay, so that was a thing. And then what happened is after we decided that this was hand over to the JST and NEDO, they regroup and then they come up with like a 6 or 7 working group, and then decide to merge some of the goals, and then now making a call. Okay, so that what happened in the government. Okay, I set the RoboCup, which is like a very private initiative. Now it's global, and I set the target of like brain circuitry, which is rather difficult if this is a government initiative. Like we get the okay, this is a great idea. We got a lot of analysis on how we're gonna do that, and then we identify like all the autonomous driver and disaster rescues and all those to be a very important 30, 40 years of the initiation RoboCup, which is about the time now. And then break down some of the technical components to find out what are the essential things, so very specific missions which everyone understands, and probably like a very inspiring, but able to push all those technical areas. Okay, and then we started in 1997, and the initial RoboCup, you see the video right now, and robot is not moving, and people think, okay, this is crazy because it's not working. Okay, and then we continue that, and what happened? This is like I have I would just like a cut off the audio. And this is a fully autonomous, not remote control. They're making their own decision. They're taking the teamwork and then moving agile. Like some of the technology for the RoboCup. I mean, we have like over 3,000 researchers worldwide, 45 countries participating in different kind of leagues. This is one of the leagues. We have 10 different leagues participating in. So, for example, like some of the participants take this technology to do the warehouse management, and they create a company called Kipa Systems, which is acquired by Amazon Robotics. And so like this is kind of technology spin-off actually completely changed the logistics system in the United States, now in the world. So this is a kind of spin-off effect of the grand challenge. Now, even though we don't achieve the goal, low-hanging fruits, we're gonna renovate, a big industrial transformation going on right now, and that's what we got. So like what it takes is imagination. If you look at the robot is not moving, can you imagine what's happening? And that's actually take a lot of inspiration and determination to go for it. And we have a lot of also we have a RoboCup robot deployed in 9/11, in the ground zero, and we have quite substantial collaborations with the U.S. This is by the U.S. team, and we deployed the robotics system to see what's going on inside and see if we can save anyone. I don't think we have I have time to really go through the whole video on this, but this is some of the social impact of what we have done in RoboCup. Okay, now and so okay, let me move to the other. Okay, now I'm trying to get a new challenge. what is the Nobel Turing challenge? Can we actually build a system which can do the science by itself? Like, can AI system to discover, make a major scientific discovery, and then possibly like win a Nobel Prize by 2050? This is really revolutionize the science. And so this is a kind of like a goal which I'm trying to initiate myself as well. So, and summary, this is the last slide. Okay, I'm going through series of like a moonshot challenge, like a RoboCup and Nobel Turing challenge myself, which is more or less a private effort, and also a government sector effort. And a big difference in the procedure, you need a procedure in the government sector because you pay, you use taxpayers' money, obviously. You need the consensus. You need to fit with the government budget framework, and you need to have the public acceptance. Where the private sector, okay, you have vision everything, right? You can be very consistent. You don't have to worry about it. But at the same time, different people have a different vision, so you got a diversity. And but at the same time, drawback the financial fragility. It's not taxpayers' money. You have to gain the momentum. You have to get the money somewhere. You have to keep going for years, and that's not guaranteed. You have the fragility, and at the same time, you have the advantage of the organizational flexibility. So there's the pros and the cons in the public sector, private sector moonshot. As the ideal thing, which my personally believe, if you get the private sector visionary read the moonshot and public sector, jumping in and those part of the process, which can take like a more the public consensus and then just by the taxpayers' money injections, I think that would be ideal. So like through the my experience going to Japanese government moonshot, my own couple of moonshot, I think that would be a very interesting synergy which we can design in the future. At the same time, moonshot have to read by someone who's crazy. I get that quote from the Stephen Jobs. But of course, someone who really believe you can change the world is the one who do. And this is the kind of person that we need to read the moonshot. Thank you very much.
Thank you, Kitano Sensei. You really covered a lot of ground, and you gave us a good feel for the breadth of the Moonshot program, and I think you gave us a good feel for how it might evolve. I mean, the Moonshot, for the audience, if you don't know about it, it's really just starting in Japan. They've been working on it all last year, preparing, sorting through the different approaches. And now they're really just now working on the 6 different goals. But you can see through the RoboCup and the other examples kind of the potential for where this is going. I'd like to turn to Dr. Gianchandani because the U.S. has been working on the 10 Big Ideas program. Everyone, I wonder if you could tell us a little bit about how the U.S. program kind of compares to Japan, and what are some of the things that you're most proud about or have hope for going forward.
Sure, happy to do that, Jim. And let me first thank you for having me on the panel. And let me also thank Kitano-san for a terrific overview of the Japanese moonshot. My congratulations to him and to our colleagues in Japan for, I think, a really impressive and compelling vision that spans a number of areas of science and engineering, and that spans a number of really important touchstones for society writ large. So let me try to answer your question, Jim, about NSF and our 10 big ideas. First, I think the folks on the panel certainly know, and many of you in the audience know, but for those who may not, the National Science Foundation is an agency within the federal government here in the US, and our mission is to support basic research in all areas of science and engineering. So my directorate at NSF, for example, the Computer and Information Science and Engineering Directorate, supports about 85% of all federally funded basic research at academic institutions throughout the United States. So a really important role for NSF in the research ecosystem. Now, we support this activity through a number of different vehicles. We have core research programs that tend to be discipline specific, and then we also have a number of interdisciplinary, multidisciplinary, and convergent research programs that span many disciplines at any given time. And so about 4 years ago, our director at the time, Dr. France Cordova, unveiled NSF's 10 big ideas. And the motivation for these 10 big ideas was really to convene the research community across all areas of science and engineering, as well as our various stakeholders, around a set of convergent research themes that span the frontiers of S&E. And so you can look at the research big ideas. There's 6 of them, for example. They stretch from harnessing the data revolution. I think we would all agree, an incredibly interdisciplinary pursuit, bringing together computer scientists and mathematicians and statisticians with folks in a whole array of science and engineering domains as well, to future of work at the human technology frontier, really rethinking how the workplace is going to look in the 21st century, particularly with the emergence of new forms of technology like AI and autonomy and so forth. And going on from there. So some of the other research big ideas include understanding the rules of life, bridging the genotype and the phenotype divide, navigating the new Arctic, bringing new sensing technology to the Arctic environment to better understand the changes that are taking place in those environments. And they go on from there. And so I think what we have seen over the course of the last 4 years, as we've had these big ideas in place and we've developed programs to support research and education activities in these big ideas, is that they've been fairly successful in focusing significant resources on a set of complex and cross-disciplinary challenges that have the potential to not only propel basic research forward, but also be able to drive innovation and economic vitality for years to come. And I think that that set of principles, bringing together complex cross-disciplinary challenges and the research communities that can pursue them, propelling research forward, aligning that innovation with economic competitiveness. Those are principles that I think very much align with the moonshot that we just heard Kitana-san describe. And to the second part of your question, Jim, about what have we seen? I think it's been really exciting for us to be able to see how interdisciplinary communities have come together around the big ideas, and how our awards are supporting students and early career researchers to really be able to innovate in ways that we would not have been able to enable previously. And if I can take just one more second, Jim, on this question, I'll just say, more recently, we've also, leveraging some of the innovation and the big ideas, started to propel investments around some of the national and societal and international challenges that we face. Artificial intelligence, you heard Kitana-san talk about that a bit. Quantum information science as well. So last fall, for example, we, NSF, partnered with other agencies in the federal government to announce a new national Artificial Intelligence Research Institute's program to try to stand up virtual centers of researchers and educators, bringing together folks from academia as well as from industry, potentially from the nonprofit world and international partners as well, to really drive forward both the foundations of artificial intelligence, machine learning, computer vision, knowledge representation, reasoning, and so forth, as well as use-inspired opportunities. So AI and agriculture, AI and medicine, reflecting back on one of the slides that Kitana-san had about the Nobel Prize. So I think across all of these sorts of investments, the big ideas, AI institutes, our investments in the quantum leap and beyond, there's really a desire to truly bring together multiple disciplines around unifying grand challenges, if I could use that term, and to try to harness the potential of discovery and innovation to be able to advance our understanding, advance our workforce, and ultimately advance our society.
Terrific. No, thank you, Erwin. It's a great overview, and that's what you touched on there, especially toward the end, is part of what really inspired me or intrigued me about when I heard about the Moonshot program. Is even if these big national programs are conceived differently, organized differently, focused on some different things, the interdisciplinary nature of them, the tools that they use, and the potential for some collaboration and synergy is interesting to me. And so let's go to the next step. Dr. Kavanaugh, the EU is just kind of finishing its Horizons 2020 program and getting ready to launch Horizon Europe, and I'd love to hear a little bit more about that and your experience with international science collaboration from you.
Good morning, Jim. Good morning, everybody. Good morning to my co-panelists, and thank you very much for the really lovely presentation on the Japanese moonshot. It was very interesting and such a huge amount to cover, but you covered it beautifully. Thank you. And I will take a minute just to give people who may not be familiar with the European Union's framework programs, just to give kind of three main highlights about what they are like before I go on to talking about the future. So our framework programs, we're very lucky in Europe. We have a 7-year budget cycle, 7 years. So this is a huge luxury, of course. And as a result, we can prepare a framework program that has a 7-year budget. So the framework program that we currently have is called Horizon 2020. Horizon 2020 will come to an end at the end of this year. It's an 80 billion euro, $80 billion, I'll try and speak in dollars, $80 billion research and innovation program. It's the largest multilateral research program in the world. It involves all of the 27 European Union member states, plus 16 countries who are associated to Horizon 2020, which means that they pay into the European Union budget and participate as if they were researchers in European Union member states. It covers all areas of research from health research, nanosciences, social sciences, all types of research are covered. And what it does, I like to explain it in this way, it at the same time promotes collaboration between European researchers and international partners on very big research issues, global challenges that cannot be tackled by one research team alone. And so what the European Union program does is it provides funding in large amounts. So we have we tend to fund very large projects in with many partners in collaborative research. But at the same time and in parallel, we fund competition between the best European scientists who can apply for funding through the European Research Council, which provides grants to individual researchers to establish a research team in Europe. By the way, those European Research Council grants are open to any researcher anywhere in the world who wants to establish a team in Europe. And also the Marie Curie fellowships, Marie Skłodowska-Curie fellowships, which are open to researchers who want to come and work in Europe for a period of up to 2 years in somebody else's lab. And by the way, those grants are also available for Europeans who want to go abroad. Horizon, and the other important thing to say is that the framework program that we have, Horizon 2020, accounts for less than 10% of the total of European research funding. Most of it resides in the member states, and most of it comes from the research programs of the member states. So what have we learned moving forward? Because next year, 2021, we will start our new framework program, which is called Horizon Europe. And I know time is very short, so I can't go into an awful lot of detail, but let me say a few things. The first is that Horizon Europe will be an evolution of Horizon 2020 and not a revolution. It's not going to be something completely different. It's going to be an evolution. So we're going to keep the things that work really well, like, for example, the European Research Council, the Marie Curie grants, the funding of collaborative research. The funding of collaborative research, and here I come to match a little bit with the Japanese moonshot, will be focused and with the 10 big ideas, which was so nicely presented as a way of focusing the efforts on a number of major research themes. So in Horizon Europe, there will be 6 what are called clusters. So the clusters, very briefly, are in the areas of health research, climate, energy and transport, actually, space, industry, and digital. I won't go into all of them, but that just gives you an idea of how broad they are. And of course, we can go into more detail later in further questions if you wish. But the novelties, what will be the novelties of Horizon Europe? Because you asked, what are the lessons learned? There'll be 2 major novelties. The first is that we will have a focus on missions. So in addition to these clusters where we will fund research on these rather broad themes, which I mentioned, it has been decided that in Horizon Europe, we have to focus also on missions. And the missions will be very clearly defined goals, which are measurable goals within a specific time frame that are close to the hearts of European citizens. So in other words, it's really science for citizens and indeed with citizens, because these missions will be co-created in a large way. The missions, which will be really like moonshots, they will be our equivalent of moonshots, will be, of course, transdisciplinary and will include elements from all of the clusters that I mentioned previously. So 5 moonshots, 5 missions have been identified on cancer, on resilience to climate change, on climate neutral and smart cities, on clean oceans and seas and waterways generally. And the 5th one just eludes me at the moment, but healthy soils and food. So these are areas that are very close to the hearts of European citizens, where European citizens really want to see an advance and see something change. And here really science and the scientific community is being offered the opportunity to really make a change. And the other big thing that we have learned and the change that we will make is we will focus more on innovation. We've always funded a lot of innovation, and in Horizon Europe, we will also introduce what's called the European Innovation Council. It's currently in a pilot phase, and the European Innovation Council will really be to help startups and small companies to develop groundbreaking, risky ideas where perhaps they might have difficulty in finding funding at the in the usual venture capital or banks. And the European Innovation Council will really be, and this is very innovative in Europe. It will provide grants to companies who are at a pre-commercial and early stage of development of their new technologies. And for more advanced, for companies that are at a more advanced stage, we will provide grants, blended finance, and we will also be able to take equity. So this is also very innovative. So I'll stop there, Jim, but I could stay talking for an hour, but I'm not going to do that to you.
That's quite all right. No, thank you so much. Well, I mean, we're covering huge spans of issues and topics, and we have a second session which will be later tonight in US time, and we'll be able to build on this from there. And then, I envision an ongoing conversation where we get a chance to look at a lot of these things in more detail, because I'm struck again by the commonality. I mean, we all face these same challenges, and our citizens are drawn to the desire and to apply these scientific and research tools and unleash the talent that we have to try to work on them. So I think this is very constructive to have this discussion. Akiishi-san, I want to turn to you, circle back to the Japan's Moonshot program a little bit. You were a driving force in taking this from an idea to realizing it. I'm wondering, kind of now that you're at this point in the program, how do you reflect upon the process to get here, or maybe you want to talk a little bit about how you see the challenges now, especially given the pandemic challenge that we face is a very tangible challenge that we're all facing, and actually interrupts and makes our collaboration more difficult.
Thank you very much, Jim. Before going to answer your question, I'd like to thank you very much for Jim to be able to arrange this meeting. Before going into the question, answering to the question, I would like to tell you that at this current moment, the G7 science ministers are talking about collaboration, not only in terms of COVID-19, but also the future cooperation. I think this cooperation would be very important for not only the response to the COVID-19, but also for the cooperation in terms of Moonshot project. And I understand the conversation at this moment among G7 ministers would be brought to the G7 leaders meeting in mid-June, hosted by United States. This is one thing. Another thing I would like to tell you is that it's really interesting. After having established this Moonshot project, Japanese government and Japanese ministries are so excited about this program that we have already get another $150 million in order to achieve another target for this Moonshot project, which would include health and medical area. So now the things are going very rapidly, even in Japan and also in the world. Now, coming back to your question, the most difficult parts of Moonshot program of Japan. And for my part, I wanted this Moonshot program to be not only Moonshot for the target, but also the Moonshot of the process itself. So I would like to revolutionize the Japanese R&D process itself. So we had a lot of agenda popped up one after another. I'll be very honest. There are 5 issues I would like to tell you. One is how to set target. This is very difficult. Another second issue is how to accommodate failure. And third issue is how to involve relevant stakeholders in this process. Fourth issue is how to choose project director who can integrate first agenda in order to achieve the target. And also the final point is how to make most of international cooperation. Now, the first is how to set the target. As long as the area is concerned, we have been able to pick up some very important area. As Kitano-san said, these areas must be challenging for Japan, and also it should contribute to the world, and also it should make most of the Japanese strength. And of course, when it comes to this condition, we would be able to pick up something like save Earth, as Kitano-san said, energy or a circular economy. And second is aging society. And third could be robotic or something like that. Now, the problem is the target, concrete target. As some people said, it should be inspiring and it should be credible and it should be imaginable. And as Arwin said, the mission timeline should be clear and goals should be clear and the target and achievement should be measurable. Now, this is very, very difficult, how wide and how narrow. When it becomes too wide, people wouldn't think it is important. When it comes too narrow, a lot of people would think that this is not my target. So it had been very difficult to let us have the good target for this Moonshot. So this is still challenging for us. I don't know whether our Moonshot target would be good enough for this challenging agenda. And the second point is how to accommodate the failure. And as long as the R&D management is concerned, we don't have the good portfolio management. When it comes to the venture capital investment, we have a lot of good portfolio management for the venture capital investment. But when it comes to the R&D, we don't have a good management portfolio. This is very important issues. And another point is that spin off and spin out is very important because the Moonshot program is very long. So if we were to ask the Japanese people to give some money to this Moonshot project, we have to let them understand that this is important and this is actually good for our life. So it is very important to have a good spin out and spin out in order to let people feel about the outcome of the Moonshot, even though this spin out or spin off would not be in line with the Moonshot program. Third issue is how to involve stakeholders or how to integrate various projects. One is how to stakeholders. As someone mentioned, a Moonshot program is a kind of a social transformation, and we have to involve people, academia, industry, and the people who are in charge of lawmaking and also politics. And we have to get the understanding of the people so that they can understand this long-term, lot of money investment is good for them. If it would be the after Corona, I don't think we would be able to, we could get the approval from the Japanese people because the people are so much concentrated on the short-term issues in order to tackle with Corona. Another important issue for the involvement is integration is data. when it comes to data, data is so vital for around the people, and it is a resource for competitiveness. So if we are to ask people to share data, it is very difficult to let them understand this is important. As you can easily, naturally understand by the G7 open science discussion, people are very much hesitant about sharing the data. So this is the third point. Another point is number 4. This is how to choose a project director. In order for the director to be able to achieve the target, it should be it should have a vitality for young people, and also it should be able to involve a lot of stakeholders, like an old man would be able to do with a lot of wisdom. And they should have a professional special expertise and also all around knowledge about everything as a generalist. And this was very difficult for Japan to have a good project director. This is 4 things. And finally, I would like to say that this is very important to have a good international cooperation. And there are a lot of methods to have a good international cooperation. Something like a big project, STAR project or ITA. This is a big project. And also there are some other international cooperation methods, something like a scholar level exchange, lead agency method, or co-funding, or just data exchanging. We wanted to have, try all the possibilities with the Moonshot project. So we had made a MOU with the United States in terms of the quantum technology. And we have just agreed on a kind of MOU between Japan and the EU yesterday, between ministers, in order to have a good cooperation in terms of Moonshot. And also we are thinking about international funding, and we are thinking about some other international corporations. These are the important issues which we will have to try to resolve. So these are the challenges we have, and I would like to share these challenges with all of you. And if there will be some, if I can say, answer to that, I'll be very happy with that. Thank you very much.
Terrific. No, thank you very much. Well, let's explore that a little bit because I already see a couple of the questions coming in through the chat function on YouTube relate and get at this issue of international collaboration. And you mentioned the G7. So let's tap the expertise on the panel a little bit. If we want to maximize information sharing and international collaboration, are there certain assets or tools that we can invest in to do this more effectively? You know, whether it's online digital libraries, certain coordinated test beds, data sharing, vetting of information for use in kind of multidisciplinary studies, kind of some kind of seal of approval that this has passed this level of scrutiny, and therefore another researcher in another country can feel confident in using it. What from your experience are some of the potential opportunities or ways to get the most out of this without creating a whole lot of bureaucracy and kind of wasted effort? And I open this up to whoever wants to jump in from the panel.
Let me say something about it. If you look at like some kind of common goals, you know, in between like Japan, Europe, and then the US, I think we can actually have a coordinated action on the specific research topic. And then each region able to have their own funding, and then we can have like a standing committee to agree on the data sharing and the standardization. That is actually exactly what's happening in the RoboCup. And RoboCup is actually a non-government organization is leading it, and each participant is getting a funding locally. There's no global funding mechanism. But like they set that all the agreements, and they get the standard by the committee. So like everything being exchanged, and there's a lot of student exchange by itself. By now, we have a quite substantial funding of the organization ourselves. So we're gonna have a scholarship exchange or research grant by ourselves as well. It's a very modest amount compared with the government, but it's having a facilitating on top of the local government funding. So I think that it's important to have like a shared goal, and I think it's not difficult to find a shared goal in some of the scientific areas, the environmental areas, life science, and if we get the set of common target, I think it's easier. I mean, I think this should be the mission oriented rather than the framework oriented.
Thank you.
Yeah,
no, that's good. Please, Erwin, and then Akish-san.
Okay, if I could just jump in there, I just want to echo what Katana-san said about trying to be able to build collaborations by virtue of trying to understand what are our shared interests, right? So you've heard a lot from several of us on the panel about the big ideas or the moonshot or Horizon 2020, Horizon EU. And I think that there's a lot of commonality there in terms of research areas and research questions that lie within those overarching frameworks. And so the question that we often ask at NSF when we think about international collaborations is to really take a step back and make sure we understand our goals and how they align, for example, with the goals of a funding agency within Japan or our partners within the European Commission, right? And as we try to understand what are those shared goals and value proposition for collaborating, then we can start to think about the processes by which we could enable those collaborations, the mechanisms. And I think you heard both Ishii-san and Katana-san say a little bit about lead agency model, for example, or bilateral joint funding opportunities. It always starts for us a little bit on the smaller side, right? We want to build those collaborations within the research community. And so that might be researcher exchanges, that might be workshops, that might be other venues by which we can better get a researcher in the US, for instance, to pair up with a researcher in the EU or in Japan or in other parts of the world. But as we start to cultivate and nurture the research community, then we start to think about ways in which we can be very deliberate about jointly funding those researchers so that they can work collaboratively across geographic boundaries. I think one of the things that we're really proud of and excited by at the same time are some of these arrangements that we have with within Japan, JST, Japan Science and Technology Agency, or NICT, the Communications and IT Agency within Japan, and with the EU as well, right? We have these bilateral, and sometimes they can be even multilateral, but largely bilateral arrangements that tend to be focused on specific areas. They tend to be bottom up in terms of how they spring about, and they tend to allow for the research community to really work collaboratively. And that's where the science is, that's where the activity is happening. And maybe I'll just add one more thing, Jim, about access to data sets and test beds and so forth. Again, we take a very, I think, deliberate approach of trying to, so NSF, for example, we don't house the data sets on our own. Rather, we turn to the research community to develop the data repositories and best practices. There's a Research Data Alliance that's international that has been funded by many different funding agencies to surface those best practices and approaches with respect to data. And in terms of test beds, I think that there are real opportunities for international collaboration in that sort of a venue. We've, for example, looked at next generation internet networking technologies and potential collaboration that might exist by having a test bed for next gen internet and future internet architectures. So I think that there are venues in that regard as well.
Interesting. Dr. Kavanaugh and then Akishi-san.
Thank you. The European Union is very, very keen on international cooperation. And as was just mentioned, just this week, we signed a letter of intent, indeed, with Japan to committing each side to exploring how we can match and link researchers and research objectives through the Japanese Moonshot and the European Union's missions, probably in Horizon Europe. Horizon 2020 and indeed Horizon Europe are, we like to say, open to the world. This means that researchers from anywhere in the world can participate in the research, in the collaborative research grants that we fund. Usually for industrialized countries, we say this is what we're bringing to the table in terms of funding, and then they bring their own funding to the table. So Horizon Europe will continue to be open to the world, indeed. We also have been working with the United States and with Japan and many other parts of the country on many other parts of the world on collaborations over the years. One example that I'd like to give that has been working very well is a collaboration that we've had with the United States, in particular on Atlantic Ocean research. Several years ago, an agreement was arrived at whereby the United States, Canada, and European Union would work together on Atlantic Ocean research. And this has been, it was called the Galway Declaration. And since then there has been really a lot of collaboration. And that collaboration involved sharing resources like research vessels, sharing which part of the ocean bed would be mapped by the different partners, but sharing the information. I think this is very important. Since then, the Atlantic Ocean Research Alliance, as it was called, has been expanded, and several other countries have also joined. Another thing then you asked about modalities and instruments that can be used to promote international cooperation. And I think that there are a couple, one very important one being the whole dimension of open science and open access to research publications and open data platforms where data can be shared in according to the FAIR principles, which is findable, accessible, interoperable, and retrievable. So I think these are very important, they're very important infrastructures to enable researchers to collaborate across the world, because you can look and see what data has already been produced in a way that's easy for everybody to access and to use. And I think these data platforms are very, very important. And of course, Europe is already committed to Plan S on open science, making all publicly funded research immediately, the results of all publicly funded research immediately available. This is something that is very important for us. It will also be applied for projects that are funded through Horizon Europe going forward in the future. So, and then the last thing I want to say are the large global research infrastructures, which are can be a real global commons. And under the G7, there's a global research infrastructures working group, which is looking at exactly this, which countries or which areas of the world have global research, have major research infrastructures that they're willing to open up to researchers from other parts of the world, to streamline in a way and to save money, because there's no point in everybody trying to build research infrastructures. So those are just some of the points I wanted to bring to the table. Thanks, Jim.
Terrific. No, thank you. I mean, not surprisingly, a very complex picture is emerging of effort that it takes to kind of link this bottom-up process, this networking of people, and you want some spontaneity and creativity and flexibility, but connecting it to money, connecting it to past work, and trying to be efficient and not constantly redoing things or reorienting what the goals are. So it's a complex picture, and it really brings, as Kitano-sensei was talking about earlier, that kind of public-private dynamic. Akishi-san, did you want to talk a little bit about some of these issues, and then I'll take some questions from our audience.
Just two things.
Sure.
Before COVID-19, we have been thinking that data sharing is very important in order to have the cooperation between researchers. So we have decided to make a data lake in terms of Moonshot projects, not only the academia paper repository, but data lake. So at this moment, we are trying to establish a kind of a system so that we can share all the data and with cooperation with the National Institution for Informatics. Now, after the COVID-19, I understand that 20 chief science advisors all over the world have already asked journals and academia to share important academic papers and data, even they are before peer review. And these data are accumulated in some very important database, something like a medRxiv in New York, and also a bioRxiv also in New York. And I understand when it comes to the AI's data, Allen Institute, AI Institute, has a tremendous amount of data in terms of COVID-19. What I would like to say is that the impact of COVID-19 has already changed the how can I say, how to share the data and how to collaborate when it is an emergency for the human beings in terms of how can I say, science. So I think we would be able to draw a lot of good lessons from this COVID-19 cooperation so that we can cooperate in the Moonshot area. That's it.
No, thank you. Before I jump to the audience questions, does anybody else want to talk a little bit more about this COVID-19 aspect and impact? Erwin, I know you had something, and then Mary.
Well, I think Mary was first. So Mary, why don't you go ahead? And
okay, go ahead, Mary.
Thank you very much. I really appreciate what was said by Dr. Akaishi, notably regarding the data lake that they're creating for the Japanese Moonshot activities as a whole. And just to mention that in Europe, we also have the European Open Science Cloud, which is a network of repositories of data, indeed, and in particular the COVID-19 data sharing platform, which was established. I think that undoubtedly, to come back to the question specifically more of COVID-19, I think that undoubtedly COVID-19 will have a big impact on how we will have an impact on how we do research moving forward. And just to link it a little bit to the previous discussion of international cooperation, I think that will be probably an increasing role for organizations like Gavi, the Global Alliance on Vaccines, and the and CEPI, the Coalition on Pandemic Preparedness, where I mean, everybody is funding research now, of course, on COVID-19. It's the global imperative in addition to climate change. And I think that organizations like this, which can have an overview of everything that's happening, and where the major research funders around the world contribute to it, in order to ensure that there is a global dimension to the research that is being done, will be extremely important going forward.
Yeah.
Thanks.
Yeah, I just want to, Jim, echo what Mary and Akaishi-san have said. I think that, we've been thinking about COVID-19 a little bit in the context of a forest fire, right? And we're hearing about hotspots emerging today, right? And so I think that that analogy is even more apropos in some sense. So when you think about a forest fire, the first step is to contain the fire. The next step is to extinguish it. And then the next step after that is to really rebuild the forest after the fire. And I think that we're seeing that we're still sort of in the containing and extinguishing phase. And there's been a lot of great collaborative effort that's been brought to bear across many countries and many research funding agencies. You heard about the G20 activity, in the wake of the emergence of COVID-19. Here in the US, we started the High Performance Computing Consortium to try to pull together a variety of different supercomputing, advanced computing resources to, across government, across industry, across academia, to really enhance access to some of the most powerful machines that we have, so that we can improve on our modeling capabilities, on our AI machine learning capabilities, to really be able to better understand not just the virus itself, but also how it spreads, manners in which we could help mitigate that spread, and so forth. And I think that we're starting to see this COVID-19 HPC consortium become international in ways, pulling together resources from across our geographic borders. And so to me, that's a short to maybe medium-term activity, but I think we're all going to have to be collectively involved too in the medium to longer-term activity of how do we resume research activities that have been on pause as a result of COVID-19, with all of us being at home. How are we going to recover lost time, for example, field seasons that have come to a grinding halt over the course of the last few months? How do we ensure our graduate students who are being trained through many of the programs that we've talked about here, right? The big ideas, Horizon 2020, the Moonshot, our graduate students, how do we support them and sustain their training and preparation so that they have a pathway forward, even if we're seeing, for example, universities not hiring as much as they may have in the past. And so I think that it's really important as we contemplate this shift to a new normal, if you will, that we think about how our shared and collective interests and convening power can really help to move the needle forward in a positive way.
Yeah, no, that's those are really good points, and the high performance computing, leveraging that asset in pursuit of the COVID-19 mission is a good example. And I want to get to, we're going to go to 10:15, which is another Eastern time, which is just another 12 minutes or so. But I want to get to a couple of the questions that have come in from the audience. The first one from Mike Nelson from the Carnegie Endowment, who runs our Technology and International Affairs program. He was asking about over the last 3 decades, there have been many international R&D programs from both big science and investigator-led projects, ITER, ISS, NIFSNet. What are some of the best and worst practices to learn kind of from those experiences in your mind, is the question he poses. Does anyone have any experience with those?
I'm not sure like if I should really name which one's best and which one is like I'm not in a position to evaluate this, but what I think is that all the big projects has a 2 distinct aspects. One is if that is more the integration engineering oriented project, or is it gonna be the basic science project? If that is like an integration engineering projects, like it makes sense to actually invest a lot of money and then get the various things organized, because like you put like a resource together, so like any single agency or organization won't be able to make it happen. So like coordinate effort makes sense. But if that is really the basic science, you need like a serendipity, or you need like crazy minds. Each funding doesn't really have to be huge. I mean, it's better to have much more diversity. So I think you got to structure somewhere in the middle. So like in the design and Moonshot, that was the difficult part actually. Moonshot, the Japanese one, designed to be a relatively it's not entirely engineering, but like a more technology-driven science acceleration program rather than the basic science. The basic science, because the important thing is that you want to define what you want to discover, and that's something you don't want actually some of the the government to decide what you're going to look into, right? Because like that loses diversity, and that's not good. You have to let like crazy mind to discover something unusual and leads to the major discovery, right? So that doesn't that's important. But like if you have to spend a little money, and then if you can go the technology-driven acceleration of the science or solutions, and that makes sense. And some of the like infrastructure you build, a database you build, that will accelerate the basic science, which is very exploitative. So I think like interplaying in between these actually is very interesting. And I think that shows something very interesting what's going on COVID right now. Is like, let me share very briefly my slide, because I'm sort of involved in some of the very quick international efforts, which I can actually show you. This is like this is like a very quick Luxembourg guy actually calling international network of the collaborators, long-time collaborators. So we have more than 200 people right now to come up with like all the database and data curation to understand what's going on, molecular interaction between this virus and the host, right? And this is going. And this is really not independent. This is like a consolidated effort. And then also like we are providing all the backup AI-based, like all the literature curation, knowledge extraction tools. So like a lot of effort to emerge. So like if you set like a target, those things spontaneously emerge as well. So like, this is like something that's a bottom up. But at the same time, if you have the policy, you have to engineer very well. You want to go for the exploratory. You want to go for like a more integration, acceleration of the platform. I think that would be the distinction. If you screw up, I think like a project is likely to be successful.
Yeah, no, thanks. And then inevitably, you're also leveraging relationships that have already existed and have been invested in before. And we'll talk about some of those in our second session between Osaka University, for example, and Lawrence Livermore National Laboratory, and other examples. So that's another component as well. Might have time for
Jim,
one more.
Can I just
sure.
build on while you're looking for the next question, maybe I'll just briefly build on what you said. I think, there are three key ingredients that I would just highlight as well, that I think dovetail with what Kitano-san said. Shared interests, bringing expertise or resources to the table, and kind of being on an equal footing. So just really briefly, in terms of shared interests, having a common perspective or a mind share around the goals or the value proposition for that international collaboration from the various parties that are involved. I think that that's really critical. We each have in our respective universities, nations, we each have a set of expertise and resources, and those can be differing, right? So I think one of the strong motivations, for example, for the NSF to have collaborated in the past with JST in the area of big data and disaster research was that there was access to data sets associated with natural disasters in Japan, and there was access to potential expertise on both sides that were somewhat unique and complementary. And so, again, trying to be able to understand what are the expertise and resources that we can bring together to harmonize. And then that third piece in terms of equal footing, I think going into the international relationship or collaboration with a sense of being on an equal footing, and that we are each bringing something meaningful to bear in this partnership. I think those are three key ingredients for at least what I've observed in terms of successful relationships.
Terrific. No, thank you. Are there any other comments the panel would like to make at this time? I may end up just closing the session. We've covered some of the questions. Another one of the questions was more specific about the Moonshot program to Kitano Sensei and Akishi-san about what are the kind of the key factors that are going to be critical to success of the Moonshot program. I think Akishi-san talked a little bit about that in his various factors, but I guess maybe I'll finish with this, is kind of, what do you think are kind of the near term, between now and the end of 2020, kind of the key goals or the things that need to get done to help make the Moonshot program a success and to effectively leverage the international collaboration component?
Yeah,
Please,
maybe I
Akishi-san.
To be short, I think that the key factor for the Moonshot is existence of crazy guy. The Moonshot is something like a project to set a crazy goal, which could not be achievable, but still ambitious people might be able to achieve. In order to make this project successful, we definitely have to have a crazy guy with intelligence. So this is my only point. Thank you.
Okay, find them. We got it. We're recruiting them right now. Well, would anyone like to make any final comments? Because otherwise, I'll close the session for this time. So then,
Just thanks for having us, Jim.
If you do the Moonshot, initial 5 years, you consider stupid. Everyone consider this is a fail. Because like things are gonna work because you do the Moonshot. In 5-10 years, things are gonna work. And if you continue to do that, you're gonna see the success. And that's difficult to pass because 99% of people, okay, this should be done. This is failure, and they have to go through that. And that's difficult part, particularly if you use the public money spending, not out of your pocket money or the private funding. And then that's how you get through that. is, saying the, oh, the stupid guy is easy, but stupid guy do is appear to be completely weird or like a nonsense, right? Someone have to protect it. Someone have a vision to protect it, to be able to explain it and let it go. Like I saw you, year one RoboCop video. Robotics is not moving. A lot of criticism. Everyone says like, Kitano-san, you should stop this. This is stupid. But I keep going on it, and they have a little big impact, and you have to get through that. And that's hardest part if you do the public funding.
Yeah, no, I can imagine. It's not a strength of the public side, is that sustainability and continuity. But we do achieve things and accomplish things, things that would not be possible without the support of government fundings and multiple governments coming together. I mean, the EU example is really interesting because the scale is huge, but when you think of it, well, it's 27 countries coming together. An incredible organizational challenge, and yet able to leverage very meaningful resources. So there's a long way to go. Mary, did you want to say?
I wanted to make just a closing remark, if that's okay, Jim, just to say that now more than ever, we're reminded that there are global challenges. And the two huge ones that are facing us right now are COVID-19 and climate change. And both of these will really require, they do require, and they will continue to require into the future, global teamwork. And that's why discussions like this and the discussions that are happening in the G7 science with the G7 science ministers this morning, and all of the other international fora where people are discussing how to move forward are so important, because we do need global teamwork at a time like this. Thank you.
Absolutely. No, thank you. I want to thank our audience for joining us today. And to our panelists, it's been wonderful getting to know you, and thank you for coming together and putting your time into this. And I look forward to continuing our conversation going forward. We'll have session 2. Keep your eye open for notices about session 2 later on today. And that's going to be a terrific panel as well. And thank you all again. And I hope you have a wonderful day and evening. Take care.
Thank you very much.